In our last video, we started with Euler's formula, which is this first equation here, and from it we derived new formulas for cosine of x and sine of x. And the reason we did that is because you can derive any of the trig identities, or at least any of the most important trig identities, using these ideas. And to give you a taste of how that actually works, we're going to look at an example. In this example, we're going to show that cosine of 2x times sine of 6x can be rewritten as 1/2 times the quantity sine of 8x plus sine of 4x. So if you needed to do the integral of this function on the left-hand side, you could replace its integrand with the function on the right-hand side, and then it would be really easy to integrate because you just use the method of substitution on these two terms. So to establish this relationship, we are going to use our formulas for cosine of x and sine of x. However, the first term isn't just cosine of x, it's cosine of 2x. So really, what I need to do is replace this x and each of the x's on the right-hand side with just 2x. That's how this formula works. Same goes with the sine of x. We didn't have sine of x, we had sine of 6x. So we're just going to take each of these x's and replace it with 6x. Next, we need to multiply these two quantities. So we're going to plug in the expressions that we just found for cosine of 2x and sine of 6x and multiply them. So this one's the cosine of 2x. This is the sine of 6x. Now we just need to do a bit of algebra. I'll start by simplifying a little bit. There's a 2 and a 2i in the denominator. So I'll factor that out to make the expression look a little bit simpler. 2 times 2i gives us 4i. Now we have a product of two binomials. The way you take the product of two binomials is by foiling. Even though we have complex exponentials, that idea doesn't change. We're still going to FOIL. So like FOIL, you start by multiplying the first terms together. And remember, when you multiply two exponentials, you're going to add their powers together. 2 plus 6 gives us 8. Now we go to multiplying the outside terms together. Now we need to add together the powers with the 2 and a -6. 2 and -6 combine to give a -4. And this term was negative, so there's negative in front of this term as well. Now we need to multiply the inside terms. So adding their powers together, -2 and +6, add to +4. And last, when we multiply the last terms, we have to add -2, -6, giving -8. So now we've fully expanded it. We just need to rearrange a bit, and we'll recognize that we actually have this expression here. So for example, I want to start by grouping together the two terms that had 8 involved, and I'll group together the two terms that had 4 together at the end. Next, I want to recognize that I can take this 4i, think of it as 2 times 2i, and then bring the 2i into the parentheses, because the formula for sine of x involves 2i in the denominators. In fact, now if you look at the first term in the parentheses, this is exactly the definition for sine of 8x. Likewise, the second term in the parentheses, that is the expression for sine of 4x. That means we're actually done. We have just shown that this is equal to 1/2 of sine of 8x plus sine of 4x. If you needed to integrate this function, you could instead integrate this function, and it would be much easier to do that.